Hello, how are you all doing? Welcome to a new Rockbot class. Today we're going to look at logical commands. We're going to start with the if logical command, which is one of the most important when it comes to programming a robot. Alright, what is the if logical command? It's a command that basically allows us to validate the request we're giving it. In other words, we specify a condition, and based on that condition, we can have it follow one path or another. So, it's important to understand that here, depending on a condition, it can take path A or path B. Now let's see how this can be done. Alright, for example, let's use the if command. With if, you'll see that we have two blocks of actions. Here, inside, you put the condition and, based on that condition and the result we get, we can execute either this block of commands or this other block of commands. Alright, how can we make a simple example of this? For example, let's do the following. Let's put, say, num here. Now let's see what num is. It's greater than 2. So we come here, click accept and go to num. And we're going to initialize it at 1. Alright, if we run it, basically what it's telling us is num is greater than 2 false. What does that mean? It means that here we've already got an answer, because num is 1. Is it greater than 2? No. So, the answer is false. Now, what happens when it's false? When it's false, it's going to execute the block of commands down here, which is the else command block. Whereas if the answer it gives us here is true, then it's going to execute the block of commands up here. Let's do a small example of what we're working on. Alright, let's put an alert here and another alert down here. So, let's write, the answer is true. And here, the answer is false. So, if we run it again, the if is going to execute exactly the block of commands down here. Notice that it didn't execute this command. Therefore, that's what we mean when we say it executes either the block of commands above, path A, or the block of commands below, path B. Now, for example, let's say that num is less than 10, which it actually is. So, let's run it. So, notice that since num, which holds the value 1, and the condition is num is less than 10, then I execute the block of commands here, the first one, path A. So, I run the alert that says, the answer is true. This is a first approach. Now, can we go further with this? Of course, obviously. So, what are we going to say? We're going to say that num is less than 10 and, which is another condition, so, and num is greater than 2. What are we saying here? What we're saying here, basically, is a condition that satisfies both. That is, and we're saying it has to meet both. Num has to be less than 10 and at the same time num has to be greater than 2. So, if we look, the variable we have here, the value is 1. Is it less than 10? Yes. And at the same time, is it greater than 2? No. So, what is it going to execute? The else command block, which says the answer is false. Let's see that. The answer is false. Good. Now, if I change num to, for example, 5, what's going to happen? Num has to be less than 10, is it? Yes. And at the same time, num has to be greater than 2, is it? Yes. So, what is the answer going to return? True. Excellent. Good. With this we're seeing how the logic of the if logical command works, which basically, depending on a condition, we're going to execute one block of commands or another. Good. Now we're going to we're going to set another condition. We're going to say, instead of and, we're going to use sorry or. In this case, we're going to say that num has to be less than 20 or num has to be greater than 50. So, look, less than 20 or greater than 50. Is it less than 20? Yes. Or greater than 50? Since I used or, the answer is true, because one or the other is satisfied. Or the other one. So, notice, the answer is true. Good. Now, what happens if I change num to 30? Let's see what happens. Is num less than 20? No, but the other condition could be satisfied. Is num greater than 50? No. So, the answer is false. Alright, let's go to a more practical example, more, useful. This one, in this sense, we're going to see much more often here. There it is. We're going to see it more often in what is, practical use. And it's basically when, for example, I open a web page, right? In this case, we will open, for example, HTTPS. There it is, www.mercadolibre.cl. Let's open the Mercado Libre page. OK. So, let's get started. Let's verify that it works correctly and effectively opens the Mercado Libre page. Good, good, good. Now we are going to do exactly what we should do in a practical example. Validate. Remember that you always have to validate the actions you take. That is, when we start an application or open a browser or a database or launch an application from scratch, that response, that action must always be validated whenever possible. In this case, it can be done through, for example, an object wait. So, let's go to the page, right-click, inspect, and look for an element that we want to find when the web page opens. So, let's look specifically for the search bar, the search input, and we're going to use its ID. We'll set it to be visible, give it about 10 seconds, and we'll have this action return the response in a variable, right? So let's see, the variable is created and the response is true, because it has indeed found it. Alright, so that's where the if statement comes in. So here we're going to use that response and take a look. What we're going to do, basically, is the following. On desktop, we're going to put an alert here. So here we meticulously document the outcome. The page successfully opened and displayed its content as intended, indicating a correct and proper loading sequence. Conversely, we also record instances where the page regrettably failed to open correctly, signifying an issue or error in the loading process. Remember that alerts are always used in the development environment, not in production bots, because when you trigger an alert, as they say, I trigger this alert, and until I manually press the accept button, it doesn't go away. Therefore, that pauses the robot during execution. We'll see later that this is exactly how it works. Alright, so what we're basically going to do is close this and run the entire robot. Basically, we're going to open this page, check that the element exists, and then, based on that response, we'll see which of the two alerts gets triggered. Alright, let's go. We run the whole robot, and we see that it opens correctly. Once it opens, it checks that response and it already sent the alert that says, the page opened correctly. Okay, perfect. Now, what happens if, for example, I make a mistake in the object validation? For instance, this is an ID, but I tell it that it's an XPath, for example. What will happen is that it will look for an XPath defined by this format. It won't find it, so it'll say, well, it doesn't exist. Since it doesn't exist, the response is false. So, it's going to execute the else block instead of executing the block above, the if block. So, it opens correctly, But since I made a mistake with what I told it to look for, it's going to say, well, I didn't find what you told me to look for. So, for me, the robot, if the robot says, no, honestly, it didn't open correctly, that's basically the function of the if. That way, we can, in some way validate all the actions we need within the robot. Now then, notice that if let's go a little further. If I need to open this browser and I have to click here, enter some text, and so on, in other words, do everything else, which would basically be performing a search, getting a price, a value, etc., etc. Notice that I have to put all those actions in the first block, in the if block, where it executes the commands in case it has opened correctly, right? Basically, just so you get an idea of how it would look, it would be something like this. With lots of click blocks, clicking, sending some text as well, clicking somewhere else here. So notice that inside this robot, inside this if, we're going to have all the commands in case it opens correctly. Whereas in the other case, if it doesn't open correctly, I just have the close browser command, because remember that if I can't get that action to be performed or executed correctly, what I need to do is stop the robot. So, to stop the robot, I come here, Script, Stop All and Exit. So, basically what I do is close the browser and stop the entire robot. That's the block of commands for the else. In other words, for in case it doesn't execute correctly. But if it does execute correctly, I have all these blocks of clicks and commands and other things that, to be honest, I might also need to do another validation inside, like right here, for example. Why did it open another page, and so on and so forth. And notice how, in a way, the information starts to get strung together and it pretty much stops being visually appealing or nice to look at. So, notice that here I'm simulating what a real robot would be like. If I start to go through it, basically it doesn't look all that good. It doesn't end up being something really aesthetic. Therefore, when it comes to building a robot, it matters not only what logic you use, but also the structure you use, because if you use a very messy or inefficient structure when reading it, basically it's going to be hard to understand. And if it's hard to understand, in the case that I have to hand that robot over to someone else, that person is going to have a hard time understanding it. And that's exactly where everything we want to do starts. What we want is to avoid wasting time, but we end up adding more and more delays. So, for that, we need to build and create a robot that is neat, efficient, well made, and has the necessary validations, but done correctly. So, what do? We're going to disable this part so you can later see the difference. What we're going to do is basically call another robot, which we'll call validate, for example. So, what I'm doing is delegating actions or tasks from the same bot to another one. Why? So that, in a way, the tasks are branched out according to the smaller robots. That is, one robot could be dedicated, for example, to extracting information from the web. Another robot could focus on extracting or manipulating data. Another robot could handle putting all that data into Excel, and so on. Well, we can also have another robot focus on, basically, validating the information. Alright, how can we do that? Well, first of all, with the logical if command. So, what I'm going to do is basically clone this and bring it here, but with one exception. Now, what I'm going to do is remember that the if block can't be left empty, meaning the block up here can't be empty because that's a logic error. Sorry. So, what we can do is an inverse validation. How do you do that? Remember that in the previous validation, I used exactly the result, which is true or false. Well, so here I can put not, meaning the opposite, of that result. What does that mean? It means that instead of if it's true, it runs this block, and if it's false, it runs this block. Now, if it's false, it runs this block because I inverted the condition, and if it's true, it runs this block. Now, a small note about this is that the else, unlike the if block, can actually be left empty. So, what we're going to use is, if I'm doing the inverse, that is, basically if it's false, it runs what's here. If the answer is false, remember that the page didn't open correctly, so what I should do, as we said before, is close the browser and, obviously, don't forget in this case to stop everything and exit. Right. Because what I'm saying here is, well, if the browser didn't open, if Google Excel didn't start, if it didn't connect through, I don't know, the Gmail account, or it didn't access the database, or I didn't get the result I wanted to get, then there's no point in the robot continuing to run. Therefore, I close everything and stop. That's what I'm telling it to do. So, what happens? I'm going to use this validation here. Look. Let's go to the script. Let's call that robot. Called valIDA, and what I'm saying is, okay, first I open the browser, I wait for the object, and in another robot I perform the validation. Now, notice that I used a variable here, right? But if I go to variables, it's not created here. If I create it, remember that I'm using the variable that's created in the parent, I mean here, right? If it turns out that I want to use the information provided by the parent, that is, the information that's here, then I shouldn't create the variable, because if I do create it, what the robot will do is look for the variable I'm using here. It'll look for it in the current robot, the one we're in now. It will find it, but since it's not connected to any information, it will always be empty. So, it will always take the empty information. Now, if that variable isn't there, meaning if it doesn't exist here in the robot, it will look for it in this robot itself, and if it doesn't find it, it will go to the parent robot. That is, it will look for it here, and since there's a result here, it will take that result to work with. So, look, if the answer isn't well, it's the opposite of what it gives me. That is, for example, if the answer is false, then, I'm going to execute the not res. What I'm saying is, if it's false, execute what's below here. I'm flipping the results, so to speak. And if it's false, execute what's here. Basically, if it's false, it's because I don't want it to run. Alright, so here I've already met the condition that if it's false, then close everything. And if it's not false, meaning if it's true, which in this case would execute here, down here, I leave it empty, because as we said before, we can leave it empty. Alright, so since this can be left empty, I don't touch it anymore, I don't modify it, and what I do is basically go to the parent robot and execute all these commands after this robot. That is to say, look closely. Right now I am simply going to grab and then carefully place all of the necessary commands directly here in this designated area. Right. I delete this. And look how neat it turned out. Look at how it was before. Obviously, if I need to perform another validation, I just add it, for X, for example, right here below, and look how tidy the robot looks now. Alright, this is one of the many ways to use if statements, logical commands, and validations. I hope this was helpful, and I'll see you in the next classes. Thank you very much.